Hello guys, good morning. I'm feeling privileged that I was invited to this Open Day event, and that is a matter of the 7 years of collaboration with SYS. So today I'm not going to talk about anything different that you have heard from Andy and Jan in the previous two presentations, but most likely I would like to show you this, which is actually where we are as Baker Hughes, that we have additive centers across the globe, but the ones that they are with red box are the ones that they have Stratasys, at least 1 or 2 Stratasys printers working on the additive center. So I'm representing the Aberdeen UK. Actually I'm based in Montrose, which is a port between Dundee and Aberdeen, and we have the non-metallic Center of Excellence for 3D printing, where in Germany we got an F450, and also in Houston we got another F900. So all the teams are collaborating for the polymer printing because we are moving ahead into production of subsea parts. So Baker Hughes is the world leader of upstream and downstream oil operations. So we are thinking that instead of having just prototypes or functional prototypes like tooling, we can also move to production, and for this reason we have invested a lot, and you are going to see our investment here. So actually we started back in 2016 by getting the first F170, as I have been informed from my predecessors. But in 2018 we got 2 370s that, to be honest, I have to admit that they are the most accurate and reliable printers that I have been working on. And then we said that we need to expand into higher end materials. So for this reason we moved to F380, F450, the 900, the PolyJet. In 2020, COVID strike, so there was no further investment. But in 2021, we got, as we have told, the first Origin in the UK, and also an F770. So if you look back and have a step back on why we have so many printers and why we are the biggest printing farm in Scotland, is the fact that we are working on emergency services. So an example that I cannot show you in this presentation was a protector for one of our Christmas trees, because we are producing Christmas trees that they are connecting the wellhead subsea 3,000 meters down to the platform, and we were needing a protector to be sourced in wood, but because of COVID it couldn't. So what we actually did, we organized the entire printing farm to print 26 different parts with jigsaws that they are going to end up in a 2.1 meter diameter protector in order to ship these 3 with a protector on down to Italy. So that is one of the key things and key objectives of having so many printers in one factory. So I'm going to tell you some success stories that we had from 2018 till today, mainly on tooling, as you can imagine, since I cannot disclose production items, but I have to assure you that we're doing also production items. But the first one, and you're going to see that the structure is like STAR, situation, task, action, results. So this elastomer replacement tool, we have plenty of elastomer seals that they need to go into cavities to seal wellheads. So we have a continuous improvement biased by the General Electric merge back in 2017. So the guys were stretching out the elastomer seals with an effect of relaxation of the elastomer. And they used to have a very big, massive metal tool with like an angle, but this tool was actually having erosion on the elastomer along with a non-controlled push. So we had 22K on non-conformities. So we were requested to have an additive solution, and an additive solution for this cap, which is actually 1.2 meter diameter, wasn't possible in one go and in one tilt. So that's why we were working on the function. So the function was to allow the elastomers to be placed into the cavities and also help these operators that they were doing around 30 minutes to do the placement, to do that in 5. So we actually created jigsaws on ASA made in F900, and also we turned the angle, we redesigned the original 2D drawing in order to allow the angle to be shallower, that is not going to allow the relaxation to happen. So based on the fact that the task duration was reduced substantially, then also they were needing only 4 people to carry the job for 5 minutes when there were 5 people in 1 hour. Plus the fact that this sort of operation was happening on many cells that we have, and people were trying to carry the metallic tool with a crane down to another cell, and now they have this tool. Every cell has a tool that is very, very cheap for us. Then that is saving around 40K. So the next one is a similar case where we imagine the trees that we got. They are actually horizontal and vertical trees. The vertical trees are going up to 9 meters tall, where the horizontal trees are going up about 3 meters tall. So the picture that I have taken here is I am 2 meters from the ground. So if you can imagine, this is a test cell. Just visualize the test cell. And the only way that they were thinking that they can have this positioning plate in the past was having a metallic plate of carbon steel, which is actually water jetted to create these small holes. And they had to carry a crane all over 8 test cells to carry on the actual plate made in carbon steel. Because we have a rule of thumb, 15 kilos and over, they have to use cranes. So the nylon 12CF having a density of 1.4 in comparison with 7.5 of carbon steel, it was 4 kilos and it could be carried on by hand and by one single person. So this lightweighting solution gave us a lot of benefits, not just on the way that it was solved. You know, the task was reduced, the duration of the task was reduced, but also we are very careful about health and safety, like John Crane that was mentioned. So we have a number of potential and number of benefit number for potential safety event that may happen. So that's why this is equating to 20K of benefits. Talking about sourcing and supply chain, which is one of the biggest challenges that we're facing as a company, and I think that every single sector. This is a chalk, this is a part of the tree, and the cap that you probably see on here, it needs to be pressure locked, and you need a very special tool. This special tool, because this was happening at the start of 2020, that was happening around 3 months, and the chalk had to be delivered to the assembly team in order to get tested and then released to the customer. So there was a screaming at me saying, "Do you have any solution, Montrose?" And I said, "Yes, we can actually redesign the whole tool and beef it up in order to undertake pressure forces. And then within 24 hours, we have this printed in 380, which is another powerful machine, I would say. And we got the cap correct. It was on hydrostatic tested. It passed it, and then it was released within a week. And to be honest, I saw the tool later on, and I took a picture to show how different it is in terms of design. But the whole project happened in November, and the tool arrived late January next year. So that is an amazing fast response that you can have, especially on emergency services like this. And that is what I like about additive manufacturing, especially with Stratasys. So next one, but not least, the pipe bend former tool. So this idea, it is a legacy bend former that we had back in 1986. That was the drawing date. So the guys, as I said, we had a manufacturing site in Montrose employing 900 people and having test, assembly, and machining and welding functions. So this is a bend former for a pipe that's around 4 millimeters diameter. And this is the schematic pipe that transfers the fluids in order to open and close the valve that we have in the Christmas trees. So this bend former, because plenty of cells are having to do this bending on different angles, this bend former was actually needed on every cell, and the initial quotation that we had at that time, it was 5,000 pounds for such a small machine, because this black thing is the bend former, the rest is the base. So every cell had the base, but this small kit had to be transferred from cell to cell. So the guy said, can you please redesign it as well, because we had only the 2D drawing. So that was redesigned, we created the model, and we printed that within 24 hours again. Okay, it was released in 2 days, because you have to have this post-process, because lots of supports were initiated during the print. But in the end of the day, it was tried. It is working for the last 3 years, and it saved a lot, because it's costing us to replace it if that breaks at any time, less than £200 at this moment of time. So imagine that since we are the center of excellence for non-metallic printing, this bend former has now been printed and shipped to Brazil, Italy, I think also in Singapore as well, because that is the beauty of having this digital inventory, that you may have lots of software that they're going to be supplied by Stratasys, but also the fact that if I have the printer in Houston, like I was saying to you, then they can print for Brazil because they are closer to Brazil. And if I need to ship something in Italy, I am the one who prints for the Italian colleagues. So the next one is the grease cleaner tool. You may think that, okay, Lampros, this is something really simple, but it's not actually, because the fittings of our pipe lays that we have on the welding rigs, they have a very specialized threads. So it is nearly impossible to actually create the thread otherwise other than very precision CNC machine. And these are greased all the way, and people with bare hands and some sort of steel bars, they were getting the grease out. So this is a continuous improvement project that we run. We actually had, we created it, we matched, in a sense, the thread on the other side. And we also measured the hands of every welding operator who was doing this operation. So we had the anthropometric design also on the grabbing phase. So This process was taking around 1 hour for 4 fittings to get the grease off, and now it's a 5 minutes task that it would allow the operator to do other things, because this is the main point, to ensure that every single step it's linear, and then it's going to allow you to do more things. So this is the FDM projects that I was sharing with you. But then we can move to PolyJet printing, which is another technology. So, sorry for the quality of the picture. These are small and big plugs that they are able to bounce back the sand blasting that you do before painting, and also ensure that the paint is not going to go to very important scenic places. And that is really good for us, because we, especially on the threads, the threads are more likely to get paint, and whenever we see paint on the thread, that is a raised NCR. So as long as we protect the thread, and in the past it was masked by the operators, it was taking a long time as well, and it wasn't that efficient in terms of post-coated components. Then now we do have designated and custom-made plugs that we are able to protect any sealing or thread face. And that is actually has, let's say, we commit, I think, a benefit of 80K. So this is a hot start mock. This is I'm saying that mock because it's not the actual hot start. The hot start is where you are able, so imagine the narrow beach, so the RV goes down to deep sea, and then it pushes up the hot start in order to close and open a valve, because it is preventing a flow of water going into the valve. So the hot start itself, in order to test other components of the assembly, had to be made in order to help the test and assembly team. So the precision that we have on the J750 allowed us not only to recreate the hot start with the elastomers that they are meant to be on here, I'm not sure. Yeah. So these are the elastomers. But not only that, we were able to have channels, because there are 2 holes on the back here. So we had channels of the fluids that we could actually get rid of by using the post-processing machines that have been offered by Stratasys. So only this one, and the fact that we have hot stubs now on every single test and assembly cell across Brazil, Singapore, and UK, we are thinking that we have even greater than 15K benefits. So the next one, the J750, even if we think that we cannot do much because there's epoxy resins and there are thermosets, we can do plenty of things, and this is a multi-material protector for a sealing phase of a flange. So when the flange was going again into the coating process, because we have plenty of spools. The spools are some sort of piping with lots of bends. Then the flanges of these spools were getting knocked out on the sealing surface, and also sometimes they were getting coated. So this multi-material protector, it was an idea of how we can actually safeguard the sealing surface, and not just for, as I said, for coating, but also for any bumping that's going to happen during a welder or anyone who's going to be next to the spool. So the idea was that the blue, if you can see the blue material is rigid, and then we printed also the soft material with Azilus 13, And the Azilus 30, it was a bit, even the 40 hardness was a bit even rigid for us, and it wasn't actually locking on the ceiling cavity. So what we were thinking of it is that we can actually do some honeycomb structure within the soft region, and then that made it very, very flexible because we had the support material within the honeycomb, because this is the function of the material jetting, and that worked really well, and we think that we have incurred 20K benefits. Another one, but as well as the safety, like I was talking to you earlier on, we were thinking that we need safety tags because there were many events of mishandling of pressure pipes. So these sort of tags were really good, especially on a multicolor advantage that is given by PolyJet. So as you can see, maximum working pressure 20 kSi, 10 kSi with different coloring, which is an amazing thing if you think about it, about the JSON50. So that is also a nice kit. We had around 5,000 safety tags made and printed within a week, which is actually a tremendous difference. It's not just the SAF, the PolyJet. If we realize the process, and if we understand the process of printing, we can make even production bits in very short time. But that is an amazing safety and health and safety project that include 10K. So I was talking about COVID, and I had a reason why I was talking about COVID. So back in 17th of March 2020, I got a call from my manager saying, Lampros, we have to do something about COVID because COVID has arrived in the UK. So the entire printing farm that I was describing earlier on has been turned from a production of subsea components or tools or prototypes to a COVID response project to assist, let's say, NHS in the UK, various care homes across Scotland. Also, I think the ambulance services in Glasgow, the Italian Red Cross, and also we were having this vision of getting an FFP3 mask made out of the J750 printer. So the visors, it's an amazing combination between the actual FDM and PolyJet machines, because the visors are made out of all the 900, 380, 370, 450, the visor stands. But on the back, we actually had an idea of multi-material strap. So the strap on the bracket with the visor base was rigid, so it could grab the visor, whereas the rest that you see is actually Azilus with very pure white, which it was elastic enough to get this to get to everyone's head. Then we were asked because I have to confess that we have a very big site which is called Neovinone in Italy, Florence, and we have very good relationship with the Italian government, and Italian Red Cross came across to us saying that we have, if we can do some salot valves. I'm not sure if you remember this full face mask that is used for divers, and it has on top this salot valve that allows you to breathe in and breathe out without absorbing water. So we got the biological accredited MED, I think MED 810, I think. We got that from SYS. We changed the material on our J750, and we started printing the salot valves. For 2 weeks we were printing salot valves, and it was really amazing on the way that we had sent them this 110 kits sent to Italian Red Cross, and we were actually in the paper the next week because it was the best replicate of the very first salot valve that was patented by a guy who shared the patent. So after this, we were working with Total Energies and Shell. It was the very first time that all these oil and gas businesses were collaborating together for a common cause. And we as the printing capability of the consortium, we realized that we are able to make FFP3 masks. So it was a long learning curve on what is needed, and after 9 design concepts, we utilized the multi-material capabilities on 100% of the J750, and we created a mask that was costing £100 to print. So this is me, the model of the smoke test, and we passed the smoke test. We actually suggested that to NHS because our let's say contacts in Dundee Hospital were telling us that they are using 15,000 masks per week. So we were proposing this mask for the doctors at least, that they don't have a personalized mask. But unfortunately it didn't came across as a sustainable solution for them. Anyway, so that is the conclusion of the different, let's say, user cases. So concluding remarks, we have done more than 400 projects. I'm telling about projects and not parts because some of the projects we are just having one. Some of the other projects we have around, I think the top is 30 different replicates. We have measured ourselves on 5 million in the last 3 years, which is actually covering us on the initial investment that we have put forward. We are partners with Stratasys for a long time now, and we're on the beta program, so I'm really glad that we can test also materials that they are about to go and get released. And we are doing our own research as well, because as it was said by Andy and Jan, they cannot do everything, guys. We need also to do our own research for certain test standards and tests that needs to be done for subsea components. So we are very glad to partner with them, and then we are, I think in the next 6 months, you're going to see a subsea component going in 3,000 meter depth. So Q&A forever to ask. Thank you. Any questions?
Does anyone have any questions for Lampros? He will be hanging around all day if you do, so feel free to grab him then if not. But other than that, thank you very much, Lampros.